Hey everyone, and welcome. The internet feels incredibly smart, right? But for decades, it was basically just a messy digital library full of documents that computers couldn't really understand. Today, we're going to dive into the amazing and pretty ambitious journey to build a web that can actually think. So let's start with this question. There are billions of pages out there. We see them, we read the words, and we totally get the context. But for a computer, it's often just a jumble of code. So where do we even begin to teach machines how to make sense of all that chaos?
Well, in the beginning, the web was a total mess. It was really the Wild West, where every developer was kind of making up their own rules as they went along. And this, as you can imagine, created a massive problem for anyone trying to build tools that could reliably process information online.
And this slide just lays it out perfectly. On the left, you've got the chaos I'm talking about. Developers would leave tags unclosed, mix up their upper and lowercase letters, or overlap code in weird ways that might magically work in one browser, but completely break in another. The goal was to get to the right side of the screen, what we call well-formed code, a single, clean, universal standard that any machine could read every single time with no guesswork. So how do you tame that chaos? Well, the first major step was a technology called XHTML. Its whole mission was to bring some strict and, frankly, much-needed discipline to web development by borrowing a set of rules from another language called XML.
So what is XHTML exactly? The easiest way to think about it is right here on the screen. You take regular HTML, the basic language of the web, and you enforce the super strict, unforgiving rules of XML on top of it. What you get is a much cleaner, more reliable language that machines can actually parse without getting confused.
Now let me tell you, these rules weren't just suggestions. They were the law. Every single tag had to be closed, no exceptions. You couldn't just overlap tags anymore. They had to be neatly nested inside each other. Everything had to be in lowercase. All attribute values needed to be wrapped in quotes. It really forced developers to be incredibly precise.
And this table just shows the difference so clearly. With good old HTML, closing your tags was, often optional. With XHTML, it was mandatory. HTML didn't care about case sensitivity. XHTML demanded lowercase. This strictness meant that any XHTML document was guaranteed to be well-formed, which made it predictable and a total breeze for machines to handle.
Okay, so the code itself was finally getting cleaned up. But you know how it is, fixing one problem often creates another. Now the page structure was solid, but what about all the links inside it? How do you make sure that links inside a document still work even if you move that document somewhere else?
Right. Imagine you have a document and it's linking to a picture in a folder called images. If a computer just sees the code images/pic.png, it has no idea where that images folder is supposed to be on the entire internet. It's basically a wandering lost link. And for a machine, that kind of ambiguity is a huge problem.
The solution was actually beautifully simple. It was called XML base. You can think of it as giving your document a home address. It's the special little attribute you add to your code that basically says, hey computer, all the relative links you see inside this block, they all start from this specific URL.
And here's exactly how it works. It's a simple three-step process. First, you set that base address, let's say example.com/data/. Then, when the computer sees that relative link, images/image1.png, it just snaps the two pieces together, and bam, you get the full unambiguous URL. So simple, so elegant, and incredibly useful.
So, let's take a breath. We've organized the code, we've fixed the links, we've brought structure to the web. But the next step, wow, it was infinitely more ambitious. This was about moving beyond just structure to achieve true machine understanding.
And this question right here is what drove the entire next phase of web innovation. Yeah, clean code is great, but it doesn't tell a computer what a price actually is or that a car is a type of vehicle. What if the web could actually grasp the concepts behind the words?
This was the incredible dream of the semantic web. The whole idea was to build a web where data was tagged with rich descriptions of its meaning. The goal? To turn the internet from just a giant library of documents for humans into a massive, interconnected database that machines could actually understand and even reason with.
Of course, a dream that big is going to require some serious tools. To make the semantic web a reality, a whole suite of new technologies had to be invented, and each one was designed to tackle a different piece of this enormous meaning puzzle.
So first up in the toolbox, semantic web services.
The big idea here was to create web services that could literally explain what they do to other programs. So, imagine telling your phone, plan a trip to Paris. It could then automatically go out, find a flight service, a hotel service, and a rental car service, and combine all their functions to build your whole itinerary, all without you lifting a finger. That's the power of machine-to-machine communication.
Okay, the next piece of the puzzle was about understanding context, and that's where latent semantic indexing, or LSI, comes in. It's this really clever mathematical method that helps search engines go way beyond simple keywords. By analyzing huge amounts of text, it starts to learn which words tend to show up in similar places. And that's how it figures out that car and automobile are related ideas, even though they're totally different words. It's like teaching a computer to read between the lines.
Then you had something called TAP, which was a more lightweight, practical approach. It was all about letting everyday people add simple, machine-readable labels to their content. So for example, you could tag the text 1999 as a price, or May 25th as a date, using a standard format that any program could instantly understand and use. And of course, if you're building a whole new kind of web, you're going to need a whole new kind of search engine, right? Well, that's where Swoogle came in. Swoogle didn't crawl regular web pages made for humans. No, it was a specialist. It crawled the web looking specifically for those machine-readable data files that were the actual building blocks of the semantic web. So, let's just quickly recap this whole incredible journey. We started out in the absolute chaos of early HTML. Then we brought order with the strict rules of XHTML. We fixed all those wandering broken links with XML base, and then we took that giant leap aiming for true machine understanding with the grand vision of the semantic web and all the amazing tools built to make it happen.
Now, this isn't just some fun history lesson. These ideas are actually more relevant today than ever before. The principles behind XHTML led to the clean coding practices we take for granted now, and the concepts from the semantic web, they're the direct ancestors of the tech that powers Google's Knowledge Graph, Siri, Alexa, and all the sophisticated AI models that are literally reshaping our world as we speak.
Which leaves us with a really fascinating final thought. For years and years, the semantic web was kind of seen as this lofty, academic dream. But now, with AI systems becoming the primary users of information online, is a web built from the ground up for machine understanding no longer just a nice idea, but an absolute necessity for the future?
Definitely something to think about. Thanks so much for joining this explainer. We'll see you next time.